Good evening, and welcome back, I guess, to our coding tutorial, which is working through the University of Helsinki's massive open online course. My name's Duncan, and I'm going to pick up today where we left off last time, which was looking at the divisible by 3. But also, I just wanted to sort of apologise for being a bit elusive the last couple of weeks. In the UK, colleges and schools have started going back, and I work in a college as a lecturer, so things have been a bit hectic. But now they've calmed down again. Hopefully I should get back to being able to deliver at least one a week. So the last video we looked at this divisible by 3, we got that working. So we're going to pick up here, which is the parameter values are copied in a method call. So as a method is called, the values of its parameters are copied. In practice, this means that both the main method and the method to be called can use variables with the same name. However, changing the value of the variables inside the method does not affect the value of the variable in the main method that has the same name. Let's examine this behavior with the following program. So here we've got our example class. It starts up here on this line, and this will be the close curly brace for it down here. We've got our main, which opens here and closes here. Inside there we've got int min equals 5, max equals 10, print numbers min max. So as soon as it hits this line number here, it's going to know that this is a method. It's going to look for that method. It's going to see that two variables need to be passed with it. So it's going to come back here, see that min is 5, max is 10, and it's going to run this code. And then let's see, so it's going to do, while min is less than max, it's going to print out min, then it's going to increment it all the while it's lower than. As soon as the minimum isn't less than max anymore, it's going to stop. It's going to come down here to this sort of close curly brace, realise that this method is now finished with. It will come back up here, read this next line, change min to 8, and then it will run the method again. And then when it's finished that, there's nothing else to run, so it'll end the example here. So we've got, when it starts at 5, so the initial first run, which is this one here, we've got 5, 6, 7, 8, 9. Then we've got system out print, which is a blank one, just to give us this space here, above that 8. And then we're running it again, but we're updating the variable min with the number 8, so it's going to be 8 to 10 rather than 5 to 10, and that's why we get the 8 and 9. So beneath you'll find the same program visualized step by step. Changing the values of the variables in the method print number does not affect the values in the main method, even though they have the same names. And when we're looking at this, we're talking about something called scope, the scope of the variable. So I'm sure they'll get to that in a bit, but while a variable is contained within a method, unless you use some different keywords, normally it's only viewable within that method. So if we try to use min, if it was initialized here, which it is, and we tried to use it outside of the method without passing it to a parameter, passing it to a method, we wouldn't be able to. I'll show you that in a bit as well. So this is just going to be stepping through it. There's 43 steps here. So you can see that it's going through all of the numbers, it's looping through this method here. And it'll keep doing that until we get to 9. Then it'll jump back up. Ooh. Then it should jump back up, there we go. Oh, it's slightly different, it hasn't got the system out there. I was waiting for that space to go in. Changes the min number to 8, and you can see that that's changed up here. And then it runs through the process again. Obviously it's a bit shorter because there aren't quite as many numbers to iterate through or loop through. There we go, and that's it. So method parameters are distinct from the variables or parameters of other methods, even if they share the same name. As a variable is passed to a method during a method call, the value of that variable gets copied to be used as the value of the parameter variable declared in the method definition. Variables in two separate methods are independent of one another. To further demonstrate this point, let's consider the following examples. We define a variable called number in the main method. That variable is passed as a parameter to the method increment by 3. So let's see what we've got here. So we've got our main, and then we've got the method increment by 3. So here we've got int number equals 1. we are... Okay, right, let's copy this actually. So let's take that and we'll put it in our TMC NetBeans. And we'll actually work through the example as well. I think that visualizing it and changing the code yourself quite often makes it a bit easier, doesn't it? Or I think it does anyway. So let's get this open. So when you're copying code in, you need to be careful of the class names and things like that. Did you notice that I copied, so actually let's do that again. So if any of you are trying to look at code on GitHub and things like that, and you've been downloading Java projects and things, which is absolutely great and it's a really good way to learn, you may find that you're having a bit of issue with class names and imports or packages. What I'll do is I'll make a note of that and I'll record a short video during the week to go through that with you and show you how to use it, because when I was learning to code, although I still am, I always found it quite challenging to get someone else's project working on my machine, especially when that person's code was using different libraries. So we're using the standard JDK, but there are other JDKs out there as well. So a popular one is the Apache Commons, which is another library that you can use and work with that is hosted by Apache. But to get it to work, you need to download their jar files. But I will go through that. Like I say, I'll make a note of that and I'll do a short video on that and how to get that working, just for those of you that are sort of really interested in looking at other people's code and progressing as far as you can. So on the example, I copied the main method and the actual method. So I'm going to replace my main method. There's nothing different in the main method. It's still the same public static void main string with the array and then the args. Okay, so let's get rid of this bit down the bottom here. Let's give it a quick run. Remember to select our main class, and then it will work through. There we go. So what I'm going to do is to drag this over here so we can see it a bit more side by side. I think for this example that might be a bit helpful. There we go, cool. Right, so what we've got here is our main. Obviously, as we know, it's the main entry point to our system. It's going to be the thing that runs first. So the very first thing we're doing is setting the variable number to be equal to the value of 1. We've got a system out print, which is this top line here. Then we are running the method, so increment by 3, and we're passing it a number. So we're passing it an argument or a parameter, and it's going to be the value 1. Okay. Here we've got our actual method, which is expecting an integer to be passed to it. We've got system.out.print the value of the method parameter number plus number. So here we're saying that it's equal to 1, which is this line here. Then we're updating number. We're getting the value of 4. And then when we jump out of this and come back up here, so to the end of this line here, and then we run this line, you'll notice that the number has gone back to 1. And that's because in this method, or in the scope of this method, the value is equal to 1. So if we were to change this slightly, so say we didn't want to pass a variable, or a parameter, sorry, if we just had a basic method here, this I think probably explains it a bit better. So we know that there's a variable that's been declared and given a value, but because it's in this method cannot see it. Okay, so there are ways around this, there are things that we can do, but it's just good to know that you've got sort of a little bit of privacy between methods in the variables and things like that. But also it can get a bit sort of tricky and challenging if you're not sort of sure of what you're doing. So if you are interested in exploring this a bit more, you could have a look at private variables. So I'll just quickly go through it, but I won't go through it in depth because I'm sure you're itching to get on with the actual lesson. So in the main class here, so from here down to here, we can actually put variables. Okay, so we've got an error at the moment, don't worry about that, that will get sorted shortly. So what we can do is use some keywords, so we can say that it's a private integer if we wanted. In fact, I'll show you the error. So hopefully this says that it can't find the static reference There we go. So I think before we looked, or I may have spoke briefly about static and non-static, although I wouldn't have gone into the explanation of what they are. But basically anything that you are calling from the main method needs to be static as well. So if I just put the keyword static in there, you can see the error goes away, all right? So if I was to, for example, take the keyword static out of this method, we get an error because it cannot be referenced from a non-static context, okay? So at the moment you don't need to understand what the keyword static means. That's fine, obviously you can research it if you want, but it's just something to be useful, just to be aware of, that is quite useful, especially when you're new to programming, because it can get quite frustrating. So what we've got here, this has gone purple, and that it kind of means it's global. Java doesn't really do global variables in the true traditional sense because it's largely an object-orientated programming language, but this is kind of as global as it gets. So we've got the keyword private here, and that means that this variable is only accessible within this class. Okay, we could change it to public if we wanted to, and we could access it in different classes if we needed to, and things like that. So again, something to be aware of, and you can see that error's gone now. Just something else that perhaps you could look into if you're interested. So let's get rid of this, back to how it was. So hopefully that little tangent helped and made a bit of sense to you guys. So the execution of the program produces the following output. We've looked at that. When the variable number is incremented inside the method, there's no issue. This, however, is not reflected in the number variable of the main program. The number variable living in the main program is different from the number variable of the method. Okay. So, not consequently, but interestingly actually, if I put that code back in, let's just put that back there, and we run it this time, you'll notice that the number is 4. So because we're updating this variable here, which can be accessed anywhere within that class, what we're doing here is totally updating this number with a new value. So let's just go back here. So this will step you through it. So like we just did, you can see that it's incrementing or stepping through these different sections of the code, and then how it's jumping sort of between the methods and then back to the main, and then it goes through the outputs at the bottom as well. The parameter number is copied for the method's use, i.e. a new variable called number is created for increment by 3 method, to which the value of the variable number in the main program is copied during the method call. The variable number inside the method increment 3 exists only for the duration of the method's execution and has no relation to the variable of the same name in the main program. So we've got a quiz here, let's have a look at that. So what does the program below print? We've got int number is equal to 10, modify number, and then it goes back here, so it should be 10. Let's give that a submit. I don't know why, but I always feel really nervous doing these because I don't pre-record them, I do it live sort of thing. And I always worry about getting the questions wrong, which is daft. Shouldn't doubt myself. Methods can return values. So I just want to quickly show you something. Just talking about return values. You see here it says return value is void. Okay, and then here return value is void. Public static void. Void is actually a return type that can be passed to the runtime, or to Java when you run it. But basically what it means is that we're not going to return a type. So although it is a return type, it's not, because it's void. A bit stupid, but there you go. Definition of a method tells whether that method returns a value or not. If it does, the method definition has to include the type of returned value. Otherwise, the keyword void is used in the definition. The methods we've created so far have been defined with the keyword void, meaning they have not returned any values. Alright, so I will quickly show you what that could look like. So let's delete this stuff here. In fact, let's delete all of it. So NetBeans has some really cool shortcuts. One of them is if you accidentally delete your main method, you can type in psvm and then press tab, just like we do with sout, and press, oh, why is that not working? It's probably because I'm outside of a method. Let's try that. There we go. So there are loads of different shortcuts that you can learn. So like PR is private, ST is static, things like that. So they're quite useful to know as well. So what was I going to show you? I totally lost track. Oh yeah, methods and return types. So we know about the void. We've already got that. So I'll just call that void method. So we're not expecting any return type, and that is our basic method, no errors, no problems. But when we start creating methods that have types, and it can be of any basic or primitive data type, so integer, well, string is included in that, char, boolean, anything like that, the method expects a return of the same primitive data type. Okay, so we could say public static int method, because I'm so good at naming methods. And then if I put the curly brace in, can you see we've got an error? And it will say that it's expecting a return type. There you go, missing return statement. So we can return anything we want. So I could return 0, which seems quite pointless. And maybe to give this a bit more context, let's just change this a bit. So we'll do a simple one. So I'm renaming the method, and I'm going to call it addition. Remember to rename is Control and R on your keyboard. And we can pass variables if we want. So we could do int num1 and int num2, although we don't have to. And we could return num1 plus num2. Okay, so the return can be quite useful, and it can make code more efficient, and it means that you're not always displaying everything to console. If you, or you know, when we press F6 and it appears up down here, and if you think about all of the programs that you use, very few of them probably use a console. They're all sort of graphical user interfaces or GUIs, so we don't need to always system out print everything. So if we run this method addition, pass it to 3 and 4, it doesn't really matter, does it, for this, and we run that, it will run successfully, but it won't actually print anything out because we haven't explicitly told it to print anything. So nothing there, but there's no red either. That's actually a successful call to that method, and that's fine because code does a lot behind the scenes. If we wanted to print it, we could add in a system out. So we could do 3 and 4. So what we're telling our code to do is to print out the return value of 3 and 4. So notice it hasn't got the double quotes around it, so it's not going to print a string value of addition 3 plus 4. In fact, let's copy that. And I will show you the difference between the two. So this is our string literal, isn't it? So hopefully you'll be looking at that thinking, that is going to print literally addition bracket 3 comma 4 close bracket. This is going to print 7. Okay, so let's give that a run. There we go. So this is our string literal, that's this one, and this one is finding this method, jumping down to it, taking these two values, so 3 and 4, and then returning num1 plus num2. So a little bit of a tangent. There are some other things that I'll show you to do with these later on as well. Not tonight, or today, sorry, but later on in the course. I've thought about a few different things that, like I said about earlier about downloading GitHub projects, things that would be really useful to me when I started out. So I'm going to do a different series of videos, but really short sort of snippets, like 1 or 2 minutes or 5 minutes each, just with, you know, useful bits of information. Some of you have been messaging me with questions, and that's absolutely fine. I'm more than happy to help. So if any questions come in, I will of course answer those as best I can as well. If you guys didn't know, or guys and girls, sorry, I'll just quickly show you. If I search for myself, and then go to the channel, and then if we go to about, it says here for business inquiries. If you just go through all of this, it'll actually send an email to me, and then I'll be able to get back to you. And like I say, I'm happy to help you guys, because learning to code, especially in Java, it can be quite horrendous. So as much time as I have, I will give you that time and help as best I can. So let's get back to this. So here we just looked at our keyword void. We looked at integers as well. So remember, it's any primitive data type. So any of the stuff that I'm saying and you're not sure what it is, like primitive data type, just Google it. So primitive data type. Oh, there we go. So there you go. There are 7 primitive data types. String is arguably, well, string in Java is not a primitive data type, but we won't go into that today. You'll notice actually that primitive data types have lowercase letters. So if you think about when you declare an integer, it's a little I, or a char is a little c. I don't think we've done chars yet. Long, so you've got loads of different number types. You've got byte, char, short, int, and long. Int is a really common one, a really popular one that we use. but it has a limit to the size of it. So -2 to the 31 and 2 to the 31 minus 1. So this is 32 bits, so this is getting into binary. All of these are sort of binary representations put in integers. You can see if you need anything larger than that, you've got 64 bits, which I don't even know what that number is, but it's a big one. We've got floating point, which is basically decimals. If you think about that decimal point, it kind of floats about and you can move it. That's what that is. We don't tend to use float. I've never really had any need to use it. Double is absolutely fine, and it's more accurate as well, apparently. But I haven't looked into that in any great detail. We've got Boolean, which is true or false, yes or no, on or off, 1 or 0, and then void, which we've been looking at quite a lot, or using quite a lot as well. Like I say, string is actually an array of characters, and an array is a block or group of similar types of data. So that's why string doesn't appear on here. So again, I'm really getting distracted tonight, sorry about this. So if I just show you, so int num is equal to 1, so you notice it's a lowercase, char initial equals d, again lowercase, but string is uppercase. Okay, so what that basically means, if you think back to the naming conventions, classes have uppercase first letters. So string is actually a class. And if you ever want to see how something works that you're using, like a method that's inbuilt, so something from the maths function, or anything really, you can hold down Control on your keyboard and click on it, on that keyword, and it will take you to where that part of the program is pointing. So if I was to click on addition, and we weren't already here, it would find the method and it would take us straight to it. So if I do that on string, it actually brings up the string class, and where is it? It goes through everything. Obviously you certainly don't need to read this at all, but look here, so public string is an array, which are these square braces of characters. Alright, so there you go, another useless handy bit of information. So let's get rid of these, and let's get back to our class. So where did we get to? So the keyword void means that a method returns nothing. If we want the method to return a value, the keyword must be replaced with the type of the return variable. In the following example, there is a method called alwaysReturn10, which returns an integer type, or int, in this case the value 10. So there you go, public static int, alwaysReturn10, and there you go, you can see it's returning 10. To actually return a value, we use the command return followed by the value to be returned, or the name of the variable whose value is to be returned. The method defined above returns an int type of value 10 when called. For the return value to be used, it must be stored in a variable. This is done the same way as regular value assignment to a variable, by using an equal sign. So what they've got there is the main method, and they're storing the return value in an integer. Okay, so always return 10. Obviously that's a bit of a pointless example, I guess, but they're basically saying that the int number is equal to the value of 10, and then there's system out printing it. The return value of a method is placed in an int type variable, as with any other int value. The return value can also be used in any other expression as well. So here we've got double number 4 is equal to 4 times always return 10 plus always return 10, which has some other maths performed on it, and then -8. So it will work out that calculation and then print out the answer here. All variable types we've encountered thus so far can be returned from a method. So we've got void, which we know, we've got int, and we've got double. Actually, yeah, I forgot we use double. They haven't mentioned string, but we can do string as well. Like I said, it can be sort of any of the primitive data types. Write a method, public static int, that returns the value 1. Okay, that's nice and straightforward for our first one, I think. So let's fix this that I've ruined. There we go. So, oh, do you know what? I've forgotten the method name already. So NumeroUno. Let's just copy that. So we're going to do pu for public, and then press tab, st and tab, and int, because we need to return integer data type. We're going to get our little error until we return that. And let's give that a run. I say run, if we run that, nothing will... I wonder if it's expecting us to call it. Does it say to call it? Write a method that returns value 1. Let's give that a test against the server and see what comes back. Well, there you go. We didn't need to call the method here at all. So that is one done. Let's give that one a close. Go back here, give it a refresh. Cool. So write a method, public static string word. The method must return a string of your choice. Okay, that's cool. So that's going to be almost identical to what we've just done. Where did this all come from? Okay. Oh, it's an old one, isn't it? Of course. Right, let's get rid of that. Let's get rid of that. And let's open this one. Cool. Oh, I've forgotten the method again. Word. How could I forget that? So we're going to do pu tab, st tab, and then string with a capital S, remember, and it's going to be called word. Open curly brace, press enter, we get our close curly brace, and then we can return. So this is going to be a bit different because it's a string, it's expecting double quotes. So we can return literally an empty space, we can return our names, you can return whatever you wish. But remember, it must be in double quotes. So let's give that a test and see what we get back. Look at that, we're whizzing through them. So there we go. Let's close this one. And then just a quick point. So I'll just quickly show you. So I'm not sure if you may have noticed that the different data types have different ways sometimes of signifying the data type. So did you notice that a char uses single quotes rather than double? So if we did public static char, when we wrong braces, sorry. When we return that, we would need to use the single quotes as well. So return C. There you go. So you can see I've used single quotes. If I was to remove that and put double quotes in there, it doesn't like it because it's expecting anything between a double quote to be a string, and we're telling it it's going to be a char. So there you go. So incompatible types, string cannot be converted to char. All right. Let's get rid of that. Right. Let's have a look at this one. See what we're going to be doing. Let's make sure we got our points first. So when execution inside a method reaches the command return, the execution of that method ends and the value is returned to the calling method. So at the moment the calling method for us is our main, but we can link methods together and we'll probably get onto that a bit later on. The lines of source code following the command return are never executed. If a programmer adds source code after the return to a place which can never be reached during a method's execution, the IDE will produce an error message. That's actually a really good point. So what have we got? So here they've put the method up there, which is fine. If we were to say anything, so if we were to put a system out here, we get the error unreachable statement. So this return, if you have a return method, is the last line of your method. All right, and then here it's saying miss and return statement because it's just getting a bit confused. So let's get rid of that. Go back here. So for the IDE, a method such as the following is faulty. Literally what we just looked at. I should really probably read this before recording it. The next method works since it's possible to reach every statement in it, even though there is source code below the return command. Okay, so this is a bit different really, because this is using a conditional statement. So if the parameter is greater than 10, return 10, and if it doesn't, do this and return whatever the parameter is. All right. So that's another way of doing it. You can use return statements in conditional logic. That's not a problem. If a method has the form public static void name of method, it is possible to return from it. In other words, to stop its execution in that place. With the return command, that is not followed by a value. So here we've got if denominator is equal to 0, system out print cannot divide by 0, and then return. And then here we've got the system out print, which shows you the basic formula of what that method is meant to do. Defining variables inside methods. Defining variables inside methods is done in the same manner as the main program. The following method calculates the average of the numbers it receives as parameters. Variables sum and average are used to help in the calculation. So we have got a lot of information here. So we've got a method which is the data type double, so whether we know there's going to be return. We're passing parameters to it, so 3 integers. We are adding those integers up and storing them in the variable sum. Then we are creating our variable average, which is equal to sum divided by 3, and then we're returning the average. One way to call the method is as follows. Okay, so they're looking at using scanners to pass the values. So if we go here, our values normally are passed statically, so we actually give them the numbers there. But yes, you can use scanners to pass the variables as well. So here we've got a user prompt, and the first value is being stored here, then the second value is here, the third, and then we are actually doing it a bit of a different way. So we're doing double average result is equal to average first, second and third, and then they're printing out that average there. So this is very similar to how I showed you to do the system out of the method that's being passed arguments or parameters, but they're storing that result here and then they're printing it out. So variables defined in a method are only visible inside that method. In the example above, this means that the variable sum and average defined inside the method average are not visible in the program, in the main program. A typical mistake while learning programming is to try and use a method in the following way. So we've looked at this already. So we've got int first, second and third, so 3, 8 and 4, average first, so 3, 8 and 4, and then trying to use the method's internal variable doesn't work. So if we pop back up here, we can see that we've got this variable average. It won't work. Okay, so it's looking for something that it cannot access. So if you think back to the example that we looked at when I showed you about putting the variable just below the class, and you can add different keywords to it like private and public, this is exactly the same thing. In the above example, an attempt is made to use the variable average that has been defined inside the method average and print its value. However, the variable average only exists inside the method average and it cannot be accessed out of it. In fact, you know what, I'll show you guys, because reading this sometimes isn't the most helpful thing, is it? So we've got a few different bits going on here. I'm going to leave them in, I'm not going to remove them, and you can get a bit more of a feel of what a program could look like as they start to get a bit busier. So we'll take this, where's our main, there it is. What I'll do is I'll comment this out so it's not distracting, and I'll paste this in. So here we've got our integers, and then we've got here average. So cannot find symbol average, so it's looking for this variable, can't find it because the variable is local to this method scope, and the variable that it's looking for cannot be found. Okay, so let's take that, get rid of it. I will show you quickly how to fix it, because there's no point in being shown a problem if you don't get an update to fix it. So there are a few different ways that we can do it. I'll just do one. So we can create a private static double called average, like that. Oh, spelled static wrong. There we go. And you can see it's gone purple. These ones have all gone purple, and that means that they're accessible globally, or like I say, as close to Java being global as it can. So let's get rid of this, uncomment those, and then delete these again, and then we're back to square one. Awesome. Above there is an attempt to use the name of the method average as if it were a variable. However, a method call has to be made. So this is very, very similar, but they haven't called it first. They haven't called it correctly. So they're missing the parentheses, and then they're missing the values that need to be passed to it as well, the first, second and third. So you can see the difference between these two. So this one doesn't have the parentheses or the braces, the brackets, all the variables being passed to it, so that's why that top one doesn't work and this one would. Here the method call occurs first, returning the value 5, which is then printed with the help of the print statement. So we've got int first is equal 5, int second is equal to 10, beginning to middle, so first to second, system out print first. So that's a method, isn't it? So it's going to jump down here, take those two variables, and then do a loop, and then print out the answer. So we've got that, we've got int middle is equal to start plus n divided by 2, while start is less than middle, system out print step, start plus plus. So it's going to be 5. There we go, cool. So calculating the return value inside a method. Oh, we've already looked at that. We looked at that exact example. So the return value does not need to be entirely predefined. It can also be calculated. The return command that returns a value from the method can also be given an expression that is evaluated before the value is returned. In the following example, we'll define a method sum that adds two values and returns their sum. The values of the variables to be summed are received as method parameters. So here we've got the parameters. Here's the return, first plus second. When the execution of the method reaches the statement return first plus second, the expression first plus second is evaluated and then the value is returned. The method is called in the following way. Below, the method is used to add the numbers 2 and 7 together. The value resulting from the method call is placed into the variable sum of numbers. Okay, so it's calling the sum method with these two arguments passed to it, and then they're being added here, and then the answer is being stored in this variable. So let's expand our previous example so that the numbers are entered by a user. So they've got their scanner, they've got their prompts, there we go, and then we've got a system out that explains what the answer is. So in the example above, the method's return value is not stored in a variable but is instead directly used as part of the print operation. The print command's execution is done by the computer first evaluating the string. The combined sum of numbers is that. The computer looks for the variables first and second and copies their values as the values of the method's sums parameter. The method then adds the values of the parameters together, after which it returns a value. This value takes the place of the sum method call, whereby the sum is appended or added to the string the combined sum of the number is. So appended means added to, prepended. If you ever hear of prepend, is to add it to the beginning of. So append is at the end, prepend is at the beginning. Since the values passed to a method are copied to its parameters, the names of the parameters and the names of the variables defined on the side of the caller have in fact nothing to do with each other. In the previous example, both the variables of the main program and the method parameters were named the same, so first and second. By accident, the code below will function in precisely the same manner even though the variables are named differently. So here we go. So we've got int number 1, int number 2, and here they are first and second. And that's fine, that's not a problem, because this is expecting actual numbers, and it will be getting those numbers. So even though the names are different, so even though this one's number 1 and this one's first, it's absolutely not a problem at all. Now the value of variable number 1 is copied as the value of the method parameter first, and the value of variable number 2 is copied as the value of the parameter second. So let's have a look at this one. What does the following program print? Int number is equal to 3, modify number, modify number, which is this one, number equals number plus 2, print static, add return, so then we've got the add return number. Okay, I believe it should be 13, but let's have a look. Sorry, the reason I believe it's 13, so here we are adding 2 to the number, but remember, it's staying within the scope of this method. But here, and here, to be fair, we haven't actually got a system out around modify number anyway, so it wouldn't print the value. This last line, we've got a system out, so it's going to display the value. It's going to call this method, add and return. We're going to pass the number 3 here, and then it's going to return the number plus 10. So it's going to be 3 plus 10 is 13. Okay, so let's see what we've got now. So summation, expand the method sum in the exercise template so it calculates and returns the sum of numbers that are given as the parameters. Create the method using the following structure. So we've got that. The output of the program 14. Okay, let's have a look. Let's just run it and see what we get first. Oh, I see. Okay, so we can do it one of two ways. So we can do int answer is equal to num1 plus num2 plus num3 so we can store the answer here like that, just put a space in there, and then we can return answer. Let's give that a run, so that hopefully should give us our 14. There we go. Or we can kind of cut this line out. So let's just, rather than having to repeat ourselves, pinch this, delete that line, and then return the calculation like that. And then let's give that a run. And there you go, we get our 14. So let's test that against the server and see what we get back. There we go, another one down. So we've got our point for this one, that's great. I'm going to stop this video here. I've already started recording the next part, so I've got these bits already and good to go, but this is actually quite a long section. So I'll check, when we get to the end of this section, I'll check part 3, or the next part of this one, sorry, just to see how long the part's going to be, and if I need to, I'll go back to doing the hour-long videos. That's absolutely fine, but I sort of done them shorter because I thought it might be easier for you guys and gals to digest. So I'll get this one finished tomorrow afternoon and evening, and I will have it uploaded for you tomorrow by 10 o'clock UK time. And until then, happy coding and good luck, and hopefully I will speak to you soon.